Well, thank you for joining our exhibit or tutorial today. This tutorial is going to be on seamless automation from sample management to screening. We are joined today by three of our partners. And for those of you who don't know who HighRes is, HighRes partners with life science organizations to implement intelligent data and lab automation workflows that empower every team member to plan and execute efficient and reproducible science. And today we're joined by three of our partners from Inveda, Pfizer, and Merck. Next, we're going to hear from Rich Frisbie from Pfizer, Groton, Connecticut, on designing HighRes systems to support high-throughput screening with state-of-the-art instrumentation, flexible assay capabilities, and integration with existing equipment. Rich Frisbie is a principal scientist in the High-Throughput Screening Lab in Medicinal Medicines in the Department of Biology and Pharmacology. Rich has been working at Pfizer in small molecule drug discovery for 20 years. He received his BS in Environmental Science and his MS in Molecular and Cellular Biology from the University of Massachusetts Amherst. After graduation, he joined Pfizer in the Discovery Science Group, where he was responsible for assay development and execution of structure-activity relationship and mode of action studies across various therapeutic disease areas.
Hello, everyone. My name is Rich Frisbie, and I'm here to speak with you all today from Pfizer. Again, as Katie said, I'd like to just reach out to say thank you to HighRes and Pfizer directors and managers in the room here for allowing me to speak with you all today. So for the purposes of my section here, I'd like to focus on some of the builds we've recently embarked on at Pfizer over the last year. So I'm more or less trying to cater to the folks here in the room that are embarking on a journey, an automation journey, either in the process of building your own lab, renovating a lab, building equipment, bringing this automation to life, and kind of our journey and some of the lessons learned along the way that we've encountered. So before going forward, I'd just like to mention the fact that I work in the the high-throughput screening group at Pfizer. We reside in the discovery biology and pharmacology group. This discovery biology and pharmacology group supports all of Pfizer's early drug discovery portfolio. So we have HTS, we have SAR lab supporting various RUs. We have a cell and a protein reagent group as part of that process as well. Just to point out here, showing here is myself along with the recent members of our lab. Our lab is fairly new. A few of us, namely Tony and myself, were the initial members of this HTS lab when we started to sort of bring it to life. And we were very quickly joined by Eric Johnson, who is now our lab head, and a few others that are in the room. I'll just pay homage to the fact that I see Jacob and Tony in the front room here. I know that Sarah and Jeremy are in the back as well. So circling back to the builds, we embarked on this journey started a couple of years ago. And so we retrospectively took a look back at what did we do at Pfizer historically, and where were we going to go with this automation moving forward. And so our goals were really up front to evaluate what we did. And so, we checked that box. We wanted to be in a 1536 well format. I'm not going to get into the details of this, but we have existing high-res equipment. So that was one of the reasons why we went with high-res. But in particular, we wanted to incorporate 10-year-old carts with brand new pieces of equipment. As you'll see with some of the systems, we wanted to build flexibility and redundancy, the ability to kind of traverse carts across labs. And one of the big ones for us was really where were we going to put this equipment from an infrastructure standpoint. And we needed to be EH&S compliant. So that was a big one for us. So without further ado, in terms of timelines to these builds, this journey for us started probably dating for 2024. But really, we got really into the design phase with HighRes, in particular, Drew and company, meeting on kind of a bi-weekly basis. And that started all the way back in, early 2024. At Pfizer, we take the years and we split them into semesters, semester 1 and 2. So that's where you see S1 and S2. I'll just pay, close attention to that. In terms of quoting and PO, we go through the design phase, the concepts of what we want to do with the build, where is it going to go? And then we cut a PO, and that's when sort of the magic starts to happen at HighRes. And so that whole process, at least for us, and you can correct me if I'm wrong, Drew, but it's about just shy of a year process, all all set. We ran into a little bit of stumbling blocks on our end, largely because in the middle here, we had a lab renovation that was also occurring. So this was a big deal for us in trying to meet the timelines for our builds in particular. For us, we did, as we'll get into it in a later part of the talk, we started production pretty much like immediately following SAT or site acceptance testing, and that was largely because of how we designed our FAT and SAT protocols with HighRes in particular. This is our lab space. Apologize for not being able to show actual photos of the lab, but this gives you a feel for what it looks like. If you could just use your imagination for a second and not see those 3 systems, we had a whole big lab that we had to demolish, and we had to move ceiling heights up and walls around. We had to embark on, plumbing and electrical and all sorts of fun stuff prior to the systems that you see here in the lab. So that was part of our process. We'll start with the system on the right called our ZCell, and then we'll move forward with our TriDoc and subsequent ACell Rail Imaging System. So going forward with the ZCell, this gives you a feel for what we built with that system in terms of, I guess, the big part of this is our largest system both by height and weight. And it also in terms of complexity, there's probably like 25 instruments or instruments on the system itself. Just paying homage to the fact that there are, in terms of dockable configurations, we have 3 docks, as well as a couple of places where we have fixed configurations. There's a lot of duality built into the system. So in terms of centrifugation, there's dual centrifuges, there's dual plate locks, there's a variety of Q1 bioshakes. Shown here in this pictorial are actually identical carts with Nexus Revity readers on them. And then underneath on the second shelf, because we like to, I talked about the flexibility aspect and being able to kind of push these carts around to different systems within our lab. We have dispensers on the bottom shelves. We did go with a prime tip-based liquid handler. This was more of a future build sort of aspect for us. We haven't used the prime very much by way of tip-based liquid handling. We do a lot of work with the prime right now, just by way of a pretty fancy storage configuration unit, as you'll see. And so it does have the Steri-Store as well. And just calling out the fact that from an EH&S compliance standpoint, anytime we work with cells at Pfizer, we had to enclose them in some kind of HEPA filtration enclosure. And so that's what you kind of see here. We have a dual shelf. On the top shelf is a Blue Cat washer, and on the bottom shelf is a Formulatrix Tempest, flanked by a HEPA on both the back side and on the top. And then if you just focus over here on the far right, we've written custom code with respect to the robotic movement. I think this is actually a 3-position lid valet. So any work that is done by way of delidding a cell-based assay plate that might come out of the Steri-Store happens within the plane of the enclosure. So everything happens under that HEPA environment. Moving on to the middle system, we call it right now the TriDoc, largely because it was essentially born out of the commissioning of what we call here our Echo FlexCart. So the Echo FlexCart, if folks in the room are familiar, it's quite a large cart. We originally were going to have this cart by way of just having it in the lab and being able to kind of drive it around. It's actually really heavy. It's tall, weighs about 600 pounds. We were going to put it in an elevator at one point, and we decided that's probably not going to happen. So what are we going to do? And so that's where the TriDoc concept come into play. So the TriDoc, there's really no central robotic system or robotic arm with this system. The arm comes with the cart itself. So, just by way of describing the FlexCart just in general, it has obviously an echo for acoustic dispensing. There's a dispenser on the bottom shelf, and it comes with everything really kind of needed to run an assay or perform any sort of liquid handling in the lab. You have your quintessential microspin, X-Peel plate lock, There's a nice plate hotel and your ACell arm. So when it's docked onto the system, we can then bring other pieces of equipment to it. So it's in its current form, it's shown to support, we'll call it a biochemical HTS. I say biochemical HTS because there's no incubator here to run a cell-based assay at the moment. We're using Prime by way of gantry storage. So we could run, 100 plate assays on this system. And then on the far right, dock number 2 is where we largely flex in a lot of our extra carts that we have available to us in our lab. What's shown here is again another Nexus Nexus cart with a liquid handler. In this case, there's a Tempest on the bottom shelf. So we're bringing liquid handling, multi-plate reader capability, storage, and then acoustics to essentially run that biochemical assay. You could also imagine that we use this system also for a lot of our plate reformatting. And so we have a lot of source plates that we'll prep either day of, night before, that kind of thing. So you could imagine that there is an extra, or we'll call it, instead of the Nexus cart here, there's another Echo cart. So we're using one Echo to shoot controls and things of that nature, and then the other Echo to kind of transfer the source plates. There is, because we're not bringing like the system itself to an actual arm in the middle, there is a reach envelope component to be aware of. And that is to say, this ACell cannot reach behind itself. It can only really reach off to the side. And that's where all of our carts, I should say all of our carts, we've taught very little carts on the system. So that is the limitation to this system, in that that there is a reach component. So while we can reach the nest of the Tempest on the bottom shelf, we have another identical cart with multi-flows that are side by side. And we can't necessarily reach those because of the way they're configured on that cart. So again, very limited ability, but still a very, very, very functional system. And then lastly, our imaging system, we call this the ACell Rail. We haven't named any of our equipment. I don't know if folks in the room tend to name their equipment. We're still kind of, in the process of doing that. But we call this system right now our ACell Rail. So very much like the ZCell, nearly all of our carts were taught on this system. So it could function as a redundant system to the ZCell. We can basically perform all of the tasks that we could do on the ZCell with maybe a slight limitation in throughput by way of cell-based assays. And we'll get into that in a second. But its main role was for imaging. And so we could do, one of our main goals with this system was to do fully automated online fixing and staining of cells. And so fixing occurs in a enclosed environment. And so this is a chemical exhaust. By way of showing an actual lab photo, you'd see ductwork that was going up and through to the ceiling. So this is by way of, there's a cutout in the front for robotic entry, and everything from paraformaldehyde staining is vented, very much just like a chemical hood would be. And then on the bottom shelf, as I talked about with the ZCell, any cell-based work has to happen under an HEPA environment. Again, paying homage to the EH&S compliance feature. We have another Tempest. So as you can see, we're kind of very Tempest savvy. They're pretty cool instruments, to say the least. There are other things on the system. I'm showing kind of the back side of the system, so you're not seeing the two docks. So you could imagine, in terms of those docks, there are those docks could be for dual Phoenix imagers or a Phoenix Plus, or they could be for Echo or another Echo. There could be for some of our other carts, like I've described in some of the other systems, with multi-label readers and things of that nature. Just also to point out the fact that we did go with Lyconics on this system. From an imaging standpoint, throughput isn't necessarily really a large concern, I guess you could say. So by way of STX44s, the total amount of plates that could be run on this system from an imaging standpoint would be 88 plates on a daily throughput. Would we ever get to that level? Not sure. Maybe. But what we largely would do with these is be able to flex between temperatures. So we could keep one at 37, one at 4 degrees, and maybe flex, say, have an imaging approach happening on one end of the system, and then also kind of in concurrent running, say, like a qPCR assay or something along those lines. Also, just to point out the fact that Lyconics can handle heavy payloads, and so very unlike the AmbiStore and or the SteriStore right now, we're working with some metal lids, and those metal lids are quite heavy, and they don't work very well with AmbiStores and SteriStores. They actually tend to crash because the spatula kind of sags when you put a big heavy metal lid on top of a plate. And the Lyconics actually do this quite well. So that was another reason for kind of having them on board. So just kind of circling back to sort of, I discussed or talked about some of our systems in terms of lessons learned. This has been a journey for us. It's been a journey for me. I've been involved with this since its fruition. The time component is huge. So it's not just about science really to put these systems together. It's about everything else. It's facilities. It's, we renovated a lab. So we actually had to talk about what the lab is going to look like. Where are you going to put electrical? Do we need data? What kinds of data do we need? Again, I talked about a couple of instances where our systems had to be compliant with EH&S. So they were huge for us in order to move forward, and safety risk assessments on on all of the systems. This was a big one. We even had an instance where we had a utility electrical drop for a system that had to be slightly angled. So we were compliant with like an electrical code aspect as well. I talked about FAT and SAT, and I talked about the ability to go right into production following SAT. This was huge. I mean, we had some experience with the design of our protocols. We worked very heavily with, I can't say enough good things about Mike Smith at HighRes. He was, fundamental in being able to sort of design our FAT and SAT protocols. So when we went right through FAT and subsequent SAT, when we had the systems installed in our lab, we were able to very quickly, almost instantaneously, jump right into production screening. So I'll use the last system, which I talked about, the imaging system. That system went into production days after our commissioner left. It was pretty awesome. We had older systems at Pfizer. So we wanted, as I talked about, integrate old carts. And what I mean by old carts is some of these carts were like 12 years old. And the question was, are they going to work on a brand new system? So with some slight modifications to some of those carts, we were able to actually do that. So that was pretty cool. Katie mentioned camera equipment. This was a must for us as well. So I won't go into detail there, other than to say you saw cartoons or engineering drawings of our systems. What you did not see was like all of the PCs that are scattered around those systems, right? And so you have to have access to those in a way to, actuate a driver or log into an Echo and do some diagnostic work or something along those lines. And so not every system has a monitor. So we rely very heavily on RDC, which is remote desktop connection, or net support. We have readers, we have multi-label readers, we have Solario, and then we have Pfizer's ultimate Pfizer network. And so when we generate data, we need to consume that data. That data is uploaded to cloud. It's uploaded to shared drives. So we needed to have data integration across the lab as well. So we embarked on that. And so that was, from a renovation standpoint, we had to kind of imagine where these systems were going to be, and then ultimately construct outlets and data ports and things of that nature to kind of make that happen. A lot of the new carts today are actually coming with 30 amp twist lock connections. So that's not just like a regular plug that you see on the wall. So when we kind of learned about that, it was like, oh, now we have to embark on this subsequent additional renovation of the lab to make sure, we have all of these carts. And what I mean by all of these carts, we probably have, 12, 15 carts. When they're not in use, they're docked somewhere or they're parked somewhere. And if they're parked somewhere, do you keep them on and running, or do you just completely shut them off? So largely, if you want them on to be able to use in an offline fashion, you need to be able to plug them in. So that was a big one as well. I talked about the PFA and the metal lid, so we'll skip that, but I'll just end with, It took a village to sort of make this happen. I can't stress that enough. So it's really not about science. It's about everybody else that is on this slide to sort of make this happen. And we go through these talks and we go to SLS and, we talk about, thanks to the directors and to the managers and things of that nature. But again, I mean, my director's in this room today. So thank you very much for allowing me to speak here. Everybody else in the lab and other lab heads as part of discovery biology. And then the folks that really kind of made this happen at Pfizer a little before my time, but I can't stress enough everybody at HighRes, point out Drew and Mike and Nick. But really it goes back to digital. It goes back to the folks in procurement that will help you get these POs through and to get the ball rolling. But it's really, and some of the other vendors as well. I mean, I worked very closely with Jem and Jordan and Brandon and Tom. I mean, they were instrumental, but really this is where all of the thanks has to go to. These are the facilities folks. We had 3 systems come. That's 3 tractor trailers worth of equipment that had to be kind of offloaded. So you need to imagine that that's like a receiving thing. That's not science. That's logistics. That's electrical. There's contractors. So I'll end there just to say thanks and happy to speak afterwards about the journey.